Welcome everyone in the Salesforce Apex Hour, and good morning and good afternoon or good evening based on your time zone. And today we are going to talk about the asynchronous process in the Salesforce. And today's speaker is Karthik. So let me hand over to Karthik. Karthik.
Thanks, Amit. Hi, everyone. Happy Saturday. And thank you for joining from across the world to listen to me talk about asynchronous processes in Salesforce. So without further ado, let's get started. And we're gonna talk about some really cool stuff. So just for people who do not know me, my name is Karthik Vishwanatha. I am a VP of Innovation at a startup called NeuroFlash. We do all Salesforce and artificial intelligence. I'm also a Salesforce MVP, and I live in Boston, United States, and I run a developer group here as well. And then you can all follow me on my Twitter handle, log on to Karthik. And I've been on the Salesforce ecosystem for more than 10 years right now, so I've seen the growth of the Salesforce. So I don't have the forward-looking statement, honestly. That's fine, I guess. I'm going to talk about the features that are on the platform today, so I'm not going to talk about anything that's coming up. So today's, again, agenda is primarily focused on asynchronous processes in Salesforce, what they mean, what it is, the background behind the asynchronous process, how Salesforce manages all these processes, jobs, and everything in Salesforce. We're going to talk about some use cases and also the different ways in which you can write Apex code to do the asynchronous processes, do a comparison between which ones to choose when, and we'll open it up for the Q&A at the end of the session. So with that, prerequisites. You need to have a PhD from MIT or a similar university. That's not true. No, you don't need to have a PhD to listen to this session. You just need to have a good understanding of Apex programming and passion to learn new stuff. That's it. This is not rocket science. I'm sure everyone who is working on the Salesforce platform knows that you can be a first citizen developer. So yeah, I did strike it off. So I know it's a nice funny way to start the conversation. So it's like, let's go. The what? So the way I organized today's presentation is the what, the why, and the how. So I'm going to talk about what asynchronous processes is, why we need asynchronous process, and how we do it in Salesforce platform. So that is the way, that is the structure in which the presentation has been organized. So I'm going to start with the what. So what is asynchronous process? So for the audience who are new to the Salesforce ecosystem, or who are in the Salesforce ecosystem for some time, or who are in the technology for some time, they might have heard something about asynchronous process. They might know at least like the terminology, right? In technology terminology, in technology terms, asynchronous process means the process that is operating independently of the other processes. So it is not really dependent on other process to finish or complete. So the diagram depicts exactly the same thing. So a process A is executing. It sends something to process B, and it is waiting for the response from the process B for it to complete. And then it picks up the execution. So that is a very standard sequential synchronous term. Old school programming, they have all this synchronous process involved. Asynchronous process, on the other side, you send a request, you don't really wait for it to complete. You just go ahead and do your stuff. It's very extremely common in the front-end programming, like JavaScript programming and all, and event-based programming, where you are not basically blocking the resources. You are not dependent, or you are not basically depending on like other processes. Like for example, if you look at like any JavaScript programming, Ajax programming, you request for something, and then you continue processing, and then you get a response. When you get a response, you take the response and then do the ongoing step with it. For example, I always give this as a real-time example, where if you are on a movie booking site or something, and you start looking at all those the slots or anything that is available for you, like the movie slot. So you're trying to book a movie slot, and then it is available. So the way it is doing it is like it presents you with a view, and then in the backend it is trying to see if a slot is being booked, or like if a seat is being taken in the backend. But it is not blocking you with that view. It presents you that one. And when a slot or when a seat is taken, it captures that asynchronously, and then it renders the page. So that's a real world example that you can consider when building about asynchronous thinking about asynchronous processing. And in Salesforce, I'll be giving you a lot more examples. I just want to make sure that you understand it from the real world standpoint. Again, so when to choose async versus synchronous? Whenever there is you need a quick and immediate action, when the transactions are very immediate and serial, and when you have like a normal governor limits, that is when you choose asynchronous ones. Versus async ones, you don't have to wait for that process to finish. You can pretty much do whatever you want to do, and the time is not a priority. It can run anytime. You're not really dependent on the time. And the advantage is that on the Salesforce platform in specific, you will be getting higher governor limits. For the audience who does not know what a governor limit is, it's a limit on the Salesforce platform that will contain your resources. It's because it's cloud-based, Salesforce has limits on pretty much everything, from the number of inserts that you can do, number of selects that you can do, the epic CPU time that we have. So with the asynchronous, you have much more larger governor limits. So why does someone actually need asynchronous processes on the Salesforce platform, and how does this function? Is always a question. Salesforce is as we call it, it's a multi-tenant environment. What that means is, think of that one as like an apartment complex, right? So in an apartment complex, the apartment complex is a building, and then you have all the different tenants living in it. Like you can own, and you can rent a house, you can live in that apartment complex. The resources like water or utilities or what are the resources, they are basically shared services. So that means all the tenants in that apartment complex are basically sharing the resources that belong to that particular apartment complex. The same way in the Salesforce, when you're thinking about cloud multi-tenant, there are multiple instances that are sharing the cloud with you. So you get a developer org, or you get like an org. That org is on an instance, and that instance can be shared by many other orgs, and the resources are limited for that instance. And that's one of the reasons why Salesforce has this governor limits. And when you started pushing all these asynchronous processes, Salesforce has to control all the processes that you are pushing, all the requests that you are making, as one of the tenants of a many tenant environment. That is what is a fairness of processing, and providing the capabilities for the transactions to happen seamlessly, giving the equal amount of preference priority to all the tenants. So how does Salesforce do that? So example is like you have multiple orgs, like you have org1, that is Karthik's, You have R2, that is Amit's. You have R2, that is Jitendra, someone else's. And all these three orgs started requesting asynchronous processes, like jobs or like whatever it is. Like they're saying, okay, I want this to happen, I want this. So everything goes into what Salesforce calls it a asynchronous queue. From there, Salesforce picks each of the jobs and then processes it. So that is how, on a high level, it happens. So let's go into the details on what the queue means. So it is a queue-based framework. So there are three terms that you need to understand in this queue-based framework when Salesforce starts getting all these different jobs in the backend. So the ones that I've highlighted, color-coded them, you see there are three different Salesforce environments, 1, 2, and 3. And each of these environments requested for process pushed like some job, like a future job or like a bad job or something. It goes into a queue. That process is called enqueuing. So everything is sitting in a queue. And workers, there are workers in the Salesforce terminology that actually pick the information, the job from the queue and send it for processing. And that process is called dequeue, taking the job or the request from the queue and then sending it for processing. And then in between, there is this thing called persist. The reason why it is called persist is that the queue should not forget from where that particular job came, what are the properties of that job. So you say like the orange box, Salesforce 1 is sending 3 jobs. How will the queue know that Salesforce 1 is requesting for these 3 jobs to be processed? So that's why it has to persist that information into the queue. So an analogy that I think I've already spoken in one of the sessions that I gave to similar is think of an immigration line. In the immigration, so if you travel across the world and all, in the immigration, what you do is like you have all the people coming and standing in a queue to get through the immigration process. And then you have all these different immigration officers. And there will be some people in between who will actually take you from the queue and then put you in front of a immigration counter. So that is exactly the same concept that we are looking at here, where the workers are taking the jobs from the queue and then sending it to the application servers for them to be processed. So that is the queue-based framework. After the queue-based framework, now comes the concept of how do Salesforce manage the queue. This again goes back to the multi-tenant architecture, where in scenarios, if the Salesforce does not have the ability to manage the queues, like if I go back to this one, what if the queue size is 10 and all the requests came from Salesforce 1 org, the orange box here? What will happen to Salesforce 2 and Salesforce 3? They are also sharing the same instance. What will happen to them? Think of this as, again, your apartment community, like one tenant is using all your water. What will happen to the other tenants? They will not have water. So to overcome that kind of problem, what Salesforce did is they build a mechanism behind the scenes that will manage how your requests are processed from within a queue. And these are all the different concepts I'm going to talk about: worker threads, extended delay, peak set, flow control, and handlers. We already talked about worker threads and handlers in a way, where worker thread is nothing but the one that is picking up, dequeuing the request. Handlers are the ones that are processing the request. So we're going to talk about delay, extended delay, peak set, and flow control. And this process or this concept or terminology, it's called multi-tenant fair share handling. As you know, it's a fair share, so everyone has to get their share fairly. No one gets more, no one gets less. Think of scenarios. So I created this is a scenario that I created. So instance 1, Salesforce 1 and Salesforce org2, org1 and org2 are assume they are sharing the same instance. Org1 creates 13 future requests that are requested, and then they are already in the queue, as you can see in the diagram. And now org2 creates 2 feature requests to the queue that are back of the queue, and then 2 more requests are created by org3. Everything is enqueued. This is very straightforward. So we say that's common. So org1 got there first, so org1 is getting processed, org2 second, org2 is getting processed, and then again 2 more org1s. That's fine. So if I throw a wrench into this concept, where I'm gonna introduce what I call a peak set size and then flow control. What's happening is org1 is getting more resources. So what I said is, I would only process maximum of 12 threads per org. That is called a flow control, where you're saying anything beyond 12 threads, I'm not processing for an instance. And then you have a peak set size of 15. Peak set size, think of that as a queue size. So that's are the available threads. That's the maximum size of the queue. So in the same scenario, think where all 13 threads are available. All the 13 are sent by the org1. But the maximum threads per org is only 12. So what's going to happen? So what Salesforce will do is, behind the scenes, it will take the 12 threads, the 13th thread, it will skip it. It will say, you have only maximum of 12 threads available. So let me skip the 13th thread. I'll put you on back of the queue. I'll put you on a delay. And let me scan for the other org requests. So it will find that there are 2 more requests coming in from the org2. So it will start scanning, and it will process those 2 versus the ones that are coming from the org1. So where the 13th request that came in from the org1, it is put on a delay. That's called a delay. So where it looks at the flow control, it looks at the peak set, and it determines that, okay, the org1 does not have any more requests available. So put it on a delay so that when the next request is available, it will process it. So that's called a delay. And peak set size, we learned about peak set size, flow control, and a delay. So let's look at a scenario where a particular org requests to occupy the entire peak set. Like it says, okay, I have 15. So what will happen to the those requests? So what it's going to do is, now Salesforce says, okay, you are trying to occupy the entire peak set. Let me put you on extended delay. We cannot process the entire thing at the same time. So it's going to put the entire thing on what they call as an extended delay. They put it on a timer. It's one thing beyond the delay, because all the requests are put on a delay. So that is called extended delay. These are the concepts. This is how the asynchronous processes, the requests that are submitted to the Salesforce work. And if it's a very, because first thing is, like as a developer on the Salesforce platform, you really do not need to know about all these concepts, because when you start writing code, you'll just write code. You don't worry what's happening behind the scenes, because Salesforce is taking care of all these things. But it's always, there will be an anxiety on like how things work, what's happening in my backend, how is Salesforce doing all these things. So these concepts, even though these are not directly applicable for your day-to-day programming, these are good to know so that you understand how exactly Salesforce is processing all the requests that are coming in to them through asynchronous processes. If it is synchronous, it's fine. Synchronous is like almost real time. Salesforce does it in a different way. But asynchronous, this is how they do it. So that's called extended delay, and the concepts of the asynchronous processing, how it works in Salesforce. The what, the why. Why do we need asynchronous processes? So the question is, what are the benefits? And what are all the different things that we can do with these async jobs or async ways of doing it on Salesforce? Obviously, there are a ton of benefits. I mean, the slide cannot fit in because there are a lot of benefits on using the async jobs in Salesforce. Definitely user efficiency, resource efficiency, scalability. We talked about fairness of processing and transactional capabilities. The most common reasons why developers go to async is the ones that are on the right side, right? They go because they wanted to avoid governor limits. They wanted to do mixed DML operations, or they wanted to manage long-running operations. So what is a mixed DML? I think that's the most common question that many ask. Mixed DML is something, it's an insert or it's a DML on a setup object and a non-setup object in the same transaction. Setup objects are, user object is a setup object, group is a setup object. There are like some setup objects. Non-setup objects are our standard, like account, contact, custom objects. Those are all non-setup objects. So if you are trying to do an insert or an update on the setup object and the non-setup object in the same transaction, then it's going to throw an error saying that mixed DML operation. So most of the times we tend to fall back. Our fallback solution is go with the synchronous process. The same thing with the governor limits. There are higher governor limits when you go with the async, just because Salesforce is giving you that flexibility to process it at some point in the future. So it can wait for the resources, it can pump in like more resources. So those are all the different benefits. Use cases. So we talked about the benefits. Now let's see what are all the different use cases when you apply it to the real world scenarios on when you have to consider thinking about using asynchronous processes. No matter what, I think integrations are the most used use case for the asynchronous process. It's period. I mean, like you do like a research and you collect the stats and all. I think the integrations will come as like the topmost use case for the asynchronous. There is one reason for it. The most common reason is like you cannot do if you are familiar with integrations, you can. There are two ways, right? One is incoming, outgoing. For the outgoing integrations, you cannot make a call out to an external system from an Apex trigger. So there itself, there is a limitation. The Salesforce is saying that if you are trying to perform an outgoing integration, you have to use asynchronous because you cannot call it out from an Apex trigger. So most of the times, we tend to write a feature method or a queuable method to basically make a call out. Why, again, like the other question is like why do we need to make a call out to an external system? So most of the times when two systems are integrated together, the data is going back and forth. It's like you create an account in Salesforce, you want that information to be reflected in your backend ERP system. So there is an integration there. So that account should go back to the ERP. And the way the integration happens is like, okay, you create an insert, you write a trigger on account, you make a asynchronous job that will send that information. The other use case that we have seen is complex calculations, where the CPU time is a lot more higher. That's when you cannot really leave asynchronous, because you're basically forcing the user to wait for the process to finish. And it most of the times it does not happen. It times out. So there is a timeout limit on the Salesforce processes. So if you try to do a complex calculation and forcing the user to wait, then it basically throws an error saying that CPU time exceeded. Instead, you make it async, and then it does the calculation. One of the classic examples is roll-up summaries on the lookup fields. That's where you are basically having a lookup object created, lookup fields created, and you want to do a roll-up summary to the parent object. Most of the times, you basically do it through asynchronously. And if there are any like large volume report runs, and if you wanted to manage reports through Sales Apex, you can do report runs. And most importantly, data migrations as well. Salesforce already has an API called Bulk API that allows you to do the data migration asynchronously, where you send the request and then it processes it in batches. It uses the same asynchronous concepts to do the data migration. But even if you want to do the data migrations using your custom Apex code and all, like writing your own APIs, the recommendation is to do it behind the scenes, not like synchronously. So these are all the different use cases that you have. So enough of talking. I think I spoke for a lot of time. So let's see if we can start looking at like how we're going to build all this asynchronous process in Salesforce, and then together write some code. How will we do it? There are many ways, many options. Actually, I think if I build a roadmap, so 10 years back, there was future, there was bad jobs, and there was future, and that's it. And there was no other way you could have done the asynchronous processing. But now you have bad jobs, you have queuable, you have future, you have change data capture, which is like the new thing that came up. Platform events, you have continuation. There are like tons of ways in which you can asynchronously write Apex code to do your business function. So let's. So I'm gonna start with the most simplest one, the future, and then we can go from there. I'm sure you might have a lot of questions. Again, I think we talked about scenarios. So future is like, again, it's the most simplest way to do an asynchronous process. It's a set it and forget it type, where you send the request and that's it. You forget about the request. You just call it, and then the job starts and then it runs. You don't really have a way to monitor it, so it's to your luck pretty much. You have to figure out a way to build some complex logging capabilities if you need to monitor it and all. But you just send it. You don't have any ability to monitor what's going on. You cannot change it. Chain like you cannot call another future method from another future method. And it is very primitive, and it does not support any like S objects or Apex objects. And obviously, it returns void because there is no. It cannot return it to anywhere, so it's just calling it. So let's try to write some code. The time would be sufficient, but I'll try. So let's say we call it you have we call it a future, and it is written at the method level. create task, and we can, I think we can pass in IDs, record ID. So that's it. It's very straightforward. And if you wanted to make a call out, you have to say call out is equal to true, and then it will allow you to make a call out from the feature method to an external system. Yeah, call out equal to true, I think. Creating from future. So very simple. So there is no like funky logic, or there is no like complex syntax to this feature. So if I wanted to call this one, let's say I'm going to call it on account count after insert. So this is not a best practice. This is just for demo purposes. I don't know if anyone actually guessed why this is not a best practice, but I'll tell you why it's not a best practice. So what I'm doing is I'm actually calling a future method from within a for loop, and there are like some limits to the future methods as well. So you can have a maximum of 50 future methods, if I'm right when I checked the last time. Maximum of some X number of future methods that you can call at the same time. So you cannot have more than that. That's one problem. The other one is this code is not bulkified. So what I meant by that one is like I'm just inserting one record at a time. So I'm just passing the ID. Just for demonstration purposes, I'm doing this. But if you are actually seriously coding it, I would recommend you to do multiple things. One is to bulkify the code. One is to make sure that you're not calling the future method repetitively in a for loop. So let's see if a task will be created when I create a new account. That's all is required, I think, name. So you can see that the job actually ran much faster. So the account is created and also the task is created, which is like really fast. Let's see if we can see. So you can see that the job type is future. That's the class future task created, and it ran. So you have like some monitoring capability saying that the job is complete, and that's pretty much it. So if you wanted to do beyond anything, beyond this thing, you cannot. That's how the feature is set up. It's a very old style capability that Salesforce said, okay, let's leave it like that, and then provide more capabilities like queuable and all. So let's go to my next slide. The next one that I want to talk about is a queuable class. We talked about future method and future method annotation. Now what Salesforce did was Salesforce said, okay, fine, this is working okay, but all our developers are like so smart that they wanted to get more capabilities from the platform for them to write asynchronous jobs. So Salesforce introduced the concept of a queuable, where you can implement an interface, and then you can invoke that queuable class, which will run asynchronously behind the scenes, providing the same capabilities of a feature method and more. So when I said more, what is more? One is the queuable is monitorable. So like you get the ID queue, the job ID, you can actually look at that one. You can even abort it. So you can go back to the Apex jobs and you can see that, and then you can click on abort, it will go up. And it's chainable. So what that means is you can chain multiple queuable jobs together. So one job finishes, from within that job, kick off another job. From within that job, kick off another job. So you can pretty much chain it, and then it is in an implementation. So there is an interface and there is an implementation. So you can define a constructor. You can pretty much send anything to the constructor. You can have private variables in the class. So it gives you more object-oriented concepts. It will allow you to like basically use that. Think of a queuable as an intermediate between future and a batch job. I should have actually changed the slides because I want, I'll talk about the badge next, but if you think of the top 3 asynchronous ways in which you can do Salesforce jobs, I would say, I would consider it's like a future is the easiest one with less capabilities. Queuable is the intermediate with somewhat capabilities. And then batch job is like the most powerful one with a lot more flexibility and capability, and a little more complex to write. So now what we are at, from the level of complexity standpoint, we are going up. We're going from the future to the queuable. And I'm going to show you how the queuable works. So if I go back to the same thing, I'm going to create a new Apex class. As I said, we have to implement queuable interface. I always get the spelling wrong, hoping. So it would be public. And as I said, you can also have a constructor defined. So I would say like a string record ID. And then what you have to do is you have to implement an interface. You have to implement the execute method for your queuable interface. Let me see this. It's a void, but you have to send the queuable context. So this is how the queuable is written. So now what we do is our core logic will be written in the execute method. And in the constructor, what I'm doing is I'm setting the private variable that I have in my class with the variable that I'm passing to my constructor. And so that I can use that variable in my execute method. And insert task. Oh, so implements. So the class compiled fine. and you can see that it's ready for us to use. So I'm going to the same trigger. Now I'll say like I will not only create a future one, but I will also create a queueable. The syntax to invoke a queueable is a little different. What you have to do is you have to create an instance of this Apex class. You have to say oops, and then pass in the record ID. So what I'm doing is, if you notice, this is a queueable task creator, which is an Apex class. And now I'm creating a new instance by passing in the record ID, which is what I defined as a constructor. So I'm passing in the record ID here. Once I have the queue job, so I can say item job ID is equal to system dot enqueue job, and then you pass in the instance of the Apex class that we created by implementing the queueable interface. That's it. So this is how, this is a future one. If I say this is a queueable implementation. I'm pretty much doing the same thing, but in two different ways. Let me see if I want to debug job ID. So let's see. Let us create another account record and see if it works. I'll go back to my accounts. I'm going to create my favorite Stark Industries. And I would say, I won't say anything. That's all is required. I'm going to save it. I have the logs open. Save it. So now, as you can see that it ran actually. So if you think about the multi-tenant fair share and Peakset, whatever I spoke about in the beginning, it's already open. So this instance has availability, so it's running the jobs to me really fast. And you can see both the tasks created. One is created from feature, one is created from queueable. Let's look at the if I can. I want to see if they can capture the job ID. Here, I think this is the one. After insert, I thought I didn't debug it. That's interesting. But anyways, let's look at the jobs to see. So you can see that this is the queueable task creator class, future task. This is the job ID for the queueable. So when you get a queueable job, you can, as I said, you have more control of the job ID. You can basically abort it. So you have an action to abort it, and you can pretty much abort it when it is queued. And you can also, from the execute. So let's say if I wanted to create another task, what you can do is you can say this one, you chain one. Actually, I think it will go into a loop. So I don't want to do it. But you can create a chain, something like this, where you can say like one global is done. I wanted to chain another one, but you have to make sure that you don't go into. So it only supports up to like I think 5 levels. So after that, it throws an error. So that's queuable. The third, and as I said, the most advanced asynchronous processing in Salesforce is using a batch class. So what is a batch? I mean, as the name says, the name implies a technique that is specifically designed to process a large volume of records. It allows you to basically do take the and then chunk it into like multiple pieces and then process it. That all is being managed by Salesforce. All we are doing is creating the batch job and then executing it. So the interface is again batchable, and you absolutely need to implement. When you implement that interface, you absolutely need to have 3 methods implemented in your batch class: the start, the execute, and finish. You have to have all the 3 methods. The start method, what the start method will do is it will give the batch job the collection of records that we are iterating over in chunks. So if assume there are 10,000 account records that you wanted to process, and the start method will take the 10,000 records, read those 10,000 records, and then it will say, I'm going to give 200 records or 1,000 records sets to the execute method for it to process. So it takes the entire batch and then it chunks it into multiple chunks for it to process. The execute method is where the processing, the core logic of those records happen. So it always performs it in loop. The start method gives the chunks, and then execute method performs a loop, saying that okay, here I'll process first 200, I'm processing next 200, I'm processing next 200. So up until the entire batch is complete. And then the finish method is the method that you can use to notify or do post processing of the job. Things like sending an email or a notification when the job is complete, or consolidating the record count of number of successful and error messages, or even invoking another job. So you can do a batch job chaining as well. So invoking another batch, you ideally do it in the finish method. And again, it is monitorable and it is abortable. So as I said, it's a global class. You can implement a batchable interface, and then it should include the start, execute, and finish. And there are 2 methods, additional interfaces that you can implement in conjunction with the database.batchable. Those are database.stateful and database.allows callouts. Allows callouts, as we saw it in the future, if you implement that interface, you will be able to make a call out to an external application from within the batch job. If you don't implement the interface, Salesforce will throw an error saying that you're not allowed to make a call out from the batch job. So you have to have that allows callouts interface implemented if you're trying to integrate with the external system. Stateful, what that means is, as I said, let's assume that you're processing 1,000 records at a time. So when the start method reads the 1,000 records, it divides it into 5 chunks of 200. Even though we are submitting one batch job, within that batch job, there are 5 additional batches that are running. And those 5 batches run one after another without the context of the previous batch. So we submitted one whole batch job for 1,000 records. Salesforce decides to split it into 5 chunks. Let's say chunk 1, chunk 2, chunk 3, chunk 4, chunk 5. So chunk 2 will not have the context of chunk 1 unless you implement this interface called database.stateful. So you might ask, like, what does context mean? What does it exactly mean? I'm going to show you what context means in the code. But what that means is, if there are any variables that you define in the class, those variables will be refreshed. Like, they'll have the default values if you don't say the stateful. So if you don't implement stateful, every time if you have a counter or something, the counter will always go to 0 in the second chunk, in the third chunk. Generally, it is helpful when you're trying to have some sort of a relation between the chunks, whether it is to consolidate the number of records that you're processing throughout the entire batch, or whether it is some variable that is dependent on the previous batch's execution. So if you wanted to have those kind of scenarios built in, you have to implement the stateful interface. Let me go back. And then again, as I said, default chunk size is 200. So if you don't specify any size, Salesforce will chunk it to 200 by default. Maximum chunk size is 2000. So where you can, if you say explicitly tell the batch to say, okay, fine, I have 10,000 records, process 2,000 records at a time. So it will take 2,000 instead of 200, and then it will chunk it that. So it's that's the scope size, and then it returns the job ID as similar to the queuable for you to monitor. So let's actually go and look at the code. I'm gonna take the example. I'm gonna call process accounts implements database dot batchable account object. Okay, stateful. So this is how you do it, and then, as I said, you have to have 3 methods. Let's update something like we'll update the account number. I thought there's, yeah. Okay, so if you look at process accounts, right? Let's see if we can fix the problems later. I'm saying process accounts implements database.batchable account, and then database for stateful. So I'm going to come to why we are using stateful. Okay. And then I'm saying this is my start method. What did I miss? That's right. So this is my start method. It's my data was no batchable context. Let me. Can. Oh yeah.
Get
Okay. Yeah.
get query locator.
Yeah. Get query locator. I put just query locator. Thanks, Amit. Always the live demos confuse me. So, anyways, thank you. So now I'm getting the query locator. I'm getting this in the start. What I'm doing is I'm querying for all the accounts from the database, and then I'm passing it to the execute method. So regardless of a number of accounts, let's say if there are 10,000 accounts, I did not put a where condition. I can put a where condition and say like, give me all the accounts or give me only selective accounts. And when it goes to execute, that is where I have to write my core logic, where what the execute method will do is it will process through the batches and then it will perform the operation. So I wanted to do an update. So I'll say whatever I'm getting, I'm gonna update. This is where I'm gonna use my account number is. So you have the account number. I'm setting the account number to 0. And then I'm setting the account number here. And then I'm saying okay, and then I'm updating records. So what is going to happen if I don't set the stateful? So first thing is like, let's see the batchable. The batchable has a start method. I'm getting the records. I'm performing some logic. I'm setting the account number value, and then I'm updating records. So this is going to iterate. So if there are 1,000 records, it will iterate over 200, 200, 200. So if I remove the stateful, what's going to happen is the account number will go back to 0 after the first chunk. So in order for that, you need to have the stateful so that the account number value is maintained. So after 200, it should go to 201, not 0. So that's why you have to have the stateful. And I think that's all is required. So let's save it and see if it works. I thought I have this get query locator correct, right?
It should be string, right?
It is a
Query should be string.
oh yeah.
You there, Karthik?
Yeah, I'm here.
Okay.
Can you hear me fine?
Yeah, now we can.
Okay. I don't know why it is throwing that error. Let me see if I can still compile it.
We're not able to see any change on your screen.
Just,
Your screen got stuck here. Now it's moving.
So anyways, so this is how you write the Apex. I would want to run this one. I don't know where the error is coming up. The beauty with the live demos.
Yeah, I just pasted a small snippet. I hope that will work.
Where is it?
In chat window. Quite like that.
Okay. It's the same thing that I did. So anyway, so I don't want to take up the time because I think we are already 1 hour beyond. Let me try what just. It can be S object as well. It can be a specific account as well. It doesn't have to be S object. Okay, I think your code worked. Let's see. So now we compiled it. If I wanted to run this one, I'm gonna run it in the execute anonymous to just test it. And as you can see, the batch Apex started. You can look at the batch jobs. And if you go back to your jobs, you should see there should be only one batch because we don't have that many records. So we have only one batch, so it processed. And if I look at the account number is 0 on this one. Oops. All the account numbers are set. Station. I guess. How do I hide this thing? Okay. The last one that I want to talk a little bit about is the schedulable class. The schedulable class is a way you can actually schedule your job to run in future. Think of this one as a wrapper on top of what you have built. So you can. So right now I talked about a batch job. So the way the batch job you are executing the batch jobs is by database.execute batch, which is the way you call it, but you're doing it real time. But if you say that if you think of a use case where a batch job needs to happen on a regular basis, you have to schedule that batch job. You say okay, I have this batch job that will process my accounts, but I want this batch job to run on a weekly basis or a monthly basis. Then what you do is you schedule it by using the schedulable interface. It is very much similar to the queuable interface. You have an execute method, and then you implement the schedulable interface, and then you schedule it. The way you schedule it programmatically is through a cron expression. So you can have a cron expression. Cron expression is a way of specifying which day, time, which day of the month, until when you want the job to be scheduled. There are a lot of examples. You can search for cron expressions, and then you'll probably get like a bunch of examples on Salesforce. So that's one of the examples, as you can see, is this one, where I say like 0:30:011 star. So it basically runs every 30 minutes past midnight on Jan 1st every year. So if you wanted it to run every hour, you just put all stars question mark, and then it runs every year, every hour. So these are a couple of examples of a cron expression. The last one, oh yeah, I think I totally forgot about this, but this is a completely new concept in Salesforce. It's called a change data capture async triggers. So until now, we've been talking about triggers as a sequential thing, like as soon as something happens on a record, a trigger is fired. We've been talking about this. But with this concept of change data capture, so if you have not heard about it, I'm sure Amit is going to have a session completely on change data capture at some point. This is a new, it's using the platform event capabilities of the Salesforce. And then Salesforce built on top of the platform events, where you're taking the publisher subscriber capability, and then you're expanding it to use asynchronous triggers. Basically, what it means is something gets changed. You can write an after insert trigger on that change, which will run at some point in the future. So it is not blocking the synchronous transactions or the page. And with this, they are introducing something called as a change event object. So the syntax is, if you actually look for the object, you will find account change event, contact change event, custom object __ change event. And then you can even publish a change. Actually, I have an example. If you search for change data capture, it's very, I would say very point and click style. If you have this change data capture, you can see that you can choose which object you want the change data capture to function on. But as soon as you choose in the backend, Salesforce creates change event objects. So if I wanted to write a trigger on that, you can say you can see account change event, and it actually creates a trigger on this object called account change event, which will run when something gets updated on the account. The same concept you can use using the platform events. Like, for example, there is a way you can actually subscribe for the changes. So let's say, I don't know if this works, but we'll see. So I subscribe to the account change event. So if I change something on the account, let's say I change the account type to, if you go here, you see that almost immediately, the account change event trigger fired, the event fired, and then you can see in this, this is an app. This is an app just subscribes to those events. So you can see the event came back here, and with all the details, you can see which account got changed, what value got changed, and other things. So the type got changed, so it has that one. And it has all the different commit user, entity name is account, change type is update, record ID is this one, account record ID. So you can see all that information passing through this one. And this is one other like asynchronous concept that is much more powerful, and you'll be hearing about this one in like the next few years. So with that, I think I kind of concluded. Let me see. So recap, we talked about asynchronous processes. We talked about asynchronous model in Salesforce and how it works, advantages of using it, use cases with like some real-time code examples, but there are a lot more complex ones as well, and types of asynchronous process. The homework that I think I would definitely recommend each of you to do is, if you are new to Salesforce platform, if you already have this badge, you don't have to worry about it. But if you don't have this badge, go on Trailhead and get this badge, asynchronous Apex badge. They're going to talk about all the concepts that I said with examples, minus how it works in the backend. So, I mean, I don't think you'll be finding that anywhere on how the Salesforce actually processes the queues and all. But that's pretty much it from my side. Thank you very much for taking more than 1 hour to listen to me. Amit?
Yeah. So there is a question from Kavya. Can you talk about continuation UI?
Very good question. I think I did not skip it wantedly. Honestly, that is a concept as well. The continuation, and then in the brackets I put UI. The terminology is very much similar to the Ajax, how you do it in JavaScript, right? For example, if you're building a Visualforce page or a Lightning component, Visualforce page is always synchronous. So, like, you have a Visualforce page that you build, and then for example, you're like trying to make a call out to the external system to get some information, and then paint it on the page, put it on the page. User clicks a button, for example, like say you have an integration to your backend, like ERP backend, and you want order information coming into your Visualforce page. User clicks a button, then user basically waits for that order information to come back. So that's all like very transactional, like synchronous. User is waiting. In Salesforce, they introduce what they call it as a continuation, where user really doesn't have to wait for that to finish. You can present something else to the user, where you can write a continuation method in the controller of the Visualforce that will pick up the response when the response comes back from the client, or the response comes back from the person that is who we are making a call out. And then when the response comes, you can have a method that will be invoked when the response comes. So it's basically not blocking the UI of the user. One of the examples that uses continuation in Salesforce is deployment status. I don't know if you have seen the deployment status, but the deployment status screen uses the concept of continuation, where if you look at the UI, it shows like all the Apex classes and all, but it automatically, so whenever it is getting back the responses from the server about like which ones are successful and all, it paints that circle. So think of that. That is what a continuation is. The same concept is applied on the Lightning components as well, which was recently introduced.
Yep. There is another question. Can you talk about in brief of calling one synchronous process from another, like calling batch job from queuable, vice versa, calling feature from batch, and vice versa, if that's possible? So how we can overcome from this kind of problems?
So that is called chaining, and you can do a call from one to another once, minus the future. You cannot really call the future from anywhere, right? But you can do a Apex chaining, batch job chaining. So you can go up to like any number of levels. In developer org, I think you can go up to 5 levels. It's I don't know if it is a problem, but it is. You have to be very careful on how you design your architecture to build something like that. because there is definitely a possibility of going into what we call a infinite. So you have to make sure that you chain your batch jobs or your queuable jobs in a way that you control those chains. Did that answer the question?
Yep. If anybody have any other question, feel free to unmute yourself and ask a question directly to Karthik.
Hey Karthik, I have one question from my side. So thank you for the session. Like you explained, like one async process can be called from, like a batch can be called from another batch. So what about other asynchronous process that can be called from a batch or from a future method or a queuable apex? Can you brief us about that?
So I don't think you can call future method from anywhere else. So that's a limitation. You can do a batch job from a queuable. I honestly, I never tried it actually. You cannot, I don't think you can go the other way around. And why would you want to do it in the first place is the question. It's like, what is the use case that you are trying to solve by mixing those asynchronous jobs?
No, just out of curiosity, we can do that, or if we can come across a scenario that
I have done so. The scenarios are again the chaining of the batch jobs and chaining of the queuable jobs makes sense because you are basically invoking the same job from same thing. But the cross invoking a queuable job from a batch job, I have not done.
So let me add one point here. So what I understood, what you are thinking, if I want to call a feature call from another feature call, so that's what you cannot do directly. But there might be some time of scenario come like, suppose if you have some trigger on account object, and from there you are making some feature call out, and parallelly you have another batch job. In that scenario, if you execute your batch job that is updating the same record on the account object, definitely it will fail because you are calling feature from the future. To overcome this kind of problem, you can use the queuable job because you can call queuable from a batch, so or vice versa. So in that scenario, you should override from the future and go to the queuable job. So there is a complex scenario based on the requirement to requirement used to come, and based on that we can change the sequence. So it's all this kind of question, to be very frank, is depend on scenario basis. So if you have, I hope like I answer your question, that's what you are looking for, right?
So again, it's not my recommendation is not to try doing cross asynchronous things. First of all, like avoid the feature if you can. Go with the queuable or a batch and be consistent across the board. If you want to try it out in the developer org for fun, it is fine. But when you go to like a real enterprise level implementations, try to be consistent across board. Make sure that when you're building it, think through the entire process on how you can define the batch jobs. What is the use case for you to chain the batch jobs? Can you control the chaining? And can you control the cross process, like bit from the queue to the batch and batch to the queue? And then make a judgment based on those things. And do not include the future thing because future is very unpredictable. Future is for simple things. Future is not for complex ones. Okay, any more questions?
Can you please, I just lost in the middle of the session. Can you please explain the delay thing again?
You want me to like do the entire thing again?
No, the delay one. The delay. The delay slide.
Oh, okay. Let's see. Okay, I'm going to do it for one more time because I'm also running late. So multi-tenant fair share handling, if you understood what the concept is, it's again because orgs are shared in like one single instance. You cannot give the entire resources for one specific org. You have to manage them. So in order to manage them, what Salesforce has two concepts is called a flow control and a peak sync. flow control is the maximum number of requests that an org can process at a given time. That is the flow control. And peak set is the overall queue size. Think of that way. And in the use case where org 1, let's say this is the delay. Let's talk about delay here. Org 1 has a flow control of 12. So, and then org 1 sent 13 requests. But the peak set is 15. So when the peak set is 15, org 2 has 2 requests sitting, org 1 has 12 requests, and then but it sent org 1 has 13 requests, but it has a maximum size of 12 flow control. So what Salesforce is going to do with that one additional request that org 1 has sent? So what it is going to do is it is going to add a delay to that one additional request, so that it can process the ones from the org 2 and some ones from the org 1. And once the delay is complete, it will take that 13 requests and it will process it. So I assume you understood the concept. It's making sure that the org 1 does not exceed its the flow control limit.
Yeah, thank you, Karthik. And even we also share the recording. So if you miss something in the initial, so you can go through the recording one more time. And I will be post that recording on our YouTube channel, Salesforce FXR. So subscribe our channel, and so that you will get the notification whenever I will upload this recording. And thank you everyone for the joining, and thank you Karthik for sharing your knowledge with us, and this is really helpful. And I hope like people are already aware of about basic concept of feature and all, but it's a good learning to know about how the Salesforce handle all this asynchronous stuff in the backend. So thank you everyone, and thank you Karthik for a great session and sharing your knowledge over the weekend. Thank you so much everyone.
Thank you.